So this is one of the few jointly offered pieces that we're going to be considering this semester. This is by Lambert and Britten. It's Laws and Conditional Statements, and I could find some stuff on Carl Lambert, but I really couldn't find anything on Gordon Britten, at least not in the hour or so that I had to investigate it. And between the two of them, he's by far the more important of the two philosophers. So not a lot of images of him. He is a fairly well-known American philosopher of science and logician, and he is pretty influential in philosophy of language circles. For those of you who've had me for philosophy of language, you know what definite descriptions are, you know what Russell's theory of definite descriptions is, you know how we use predicate logic in order to reveal the full logical structure of definite descriptions. That is, it's not just descriptive phrases that begin with the word the, like the present king of France. It's statements that contain definite descriptions, like Russell's famous example, the present king of France is bald. How do we evaluate the truth of that statement? The problem is because there is no present king of France. So if we just say it's false, it could be false because there isn't a present king of France, or it could be false because he's not bald. So Russell has us symbolize statements that contain definite descriptions in a very particular way, and this is Russell's way of handling it. He has his own way of handling it. He has his own theory of definite descriptions, and it comes out of this free logic theory, which basically says that we shouldn't assume that we're making an explicit existential claim when we use phrases like the Morning Star or the present king of France. I don't have time to get into definite descriptions in this class. In any event, if you're interested in that sort of thing, he's actually someone you might want to consider reading. So I identified a couple of pieces that he wrote. He taught at University of California, Irvine for a very, very long time. And he's still alive, and he's very, very productive in terms of all this stuff. So I have nothing on Gordon Britten. So let me get out of this, go to, where is it? Go to, I've got two, hold on. Where did you go? Well, I'll just have to go back to here then. They've installed Chrome, which is good. Hopefully it won't crash, but I'm just having trouble. There it is. It's what? All right. So laws and conditional statements. Lauren, turn it over to you.
So our purpose in this piece is to define the criteria necessary for a statement to be a law in order to firmly distinguish laws from generalities. And they open by talking about the scope of this argument. And laws are statements that express regularities. The properties of laws will be properties of statements, namely that they have truth values. This is not to be confused with generalizations, which are taken as statements, but are actually what statements of a certain kind express. We will restrict our attention to the simplest form of laws, in which they are a non-statistical, generalized conditional statement of the form for any, or every, or all objects, X. If X is such and such, then X is so-and-so, which I went ahead and symbolized in predicate logic.
Let's identify the parts there. So what's the UX?
The U of X is the antecedent.
Well, sort of, right? Because strictly speaking, what we've got here is a universal affirmative. So Jonathan posted something on the Philosophy Club website on Facebook, which I really got a kick out of, that albino raven, right? But let's symbolize all ravens are black, which for many, many years was a classic example of a universal affirmative. So if I were to write that in English, all R-A-V-E, ravens are black. And I were to symbolize this in the language of classical logic, it would be all R, B, where R equals ravens and B equals black things that are black individuals. We'll just say black things. Okay, can you see that? My penmanship sucks. This is how we would fully translate what this statement asserts in English into the language of classical logic. But we have another logic, in fact, a much, much more powerful logic, And that logic would require us symbolizing it this way. For any x, if it's an R, then it's a B. This is a universal affirmative statement expressed in the language of predicate logic. This is the same universal expressed in the language of classical logic, and this is that universal affirmative expressed in the language of English. This is a statement, this is a statement, and this is a statement. Statements have truth values. So in order for any of these statements to be true, every single member of this class must be a member of this class. If we can find a single raven that's not black, then what this universal affirmative asserts, what this universal affirmative asserts, and what this one in English asserts would be false. You with me here? So strictly speaking, in your example, UX is not the antecedent, right? This is a statement that has sort of the form of a conditional, but it's not a conditional. Conditionals are truth functional compound statements. This is clearly an atomic statement. Atomic statements are statements that do not have another statement as a component. When we symbolize it this way, it sort of looks like, well, you've got this conditional embedded within it, but that's really not the case, which means that it's sort of useful for us to use the logic ease that he's employing here, that is for any x. So we interpret this x, we don't say open paren x, close paren when we're reading this, we say for any x. If it's an R, then it's a B. So this x is referring to, the x out here. You can't say it's an R is a component of what's being asserted here. It's part of the logical structure, sure, but it would be wrong to say that this contains a statement within it such that it ends up being a compound. So if I were to say all ravens are black, I'm saying exactly the same thing as if I were to say if something's a raven, then it's black. Yes?
R of x be the, I don't want to say subject, but the R of x, would it be better to call it the subject than the consequence?
Well, in this way of symbolizing things, this is what's called the subject term. This is what's called the predicate term. And both subject terms and predicate terms are strictly speaking predicates. Predicates define some trait, property, or attribute that a class of individuals has. I don't think it'd be right to call this the subject term as such, right?
It's not like they have equal claims to the subject term, because we're not saying if it's black, then it's a raven. So there does seem to be a difference, like that if instantiates in terms of how we can.
Well, what if allows us to do is to identify, in this case, an antecedent condition that might need to be met in order for this, that is the consequent, to occur. Well, we have to use sort of scare quotes around the use of antecedent here, because strictly speaking, this is not a conditional. Okay? If we were to instantiate, that is, this is a universal affirmative. If we were to say, you've got a raven, call it Biff, right? So if Biff is a raven, then Biff is black. Well, that would be a conditional. But since we're generalizing over an entire class of individuals, namely a class of ravens, and what we're saying is that every single member of that class is a member of this class, we're just sort of limited by the language here. This isn't a conditional, but it's sort of in conditional form. That is, when you look at the inside of it. But all that, and that way of expressing it just allows us to sort of more accurately capture the logic of what's being asserted. That is, any universal affirmative, any statement of this form, all S is P, can be put in the form of, if something's an S, then it's a P, which sort of has the form of a conditional. That is that if-then, but it ain't a conditional.
So when he talks of conditional statements are above and beyond it, it's improper since this is an entirely different form of a statement, or an entirely different type of a statement.
It's a different type of a statement than a conditional, but this is the same use of conditional that Hempel was using in the last class when we were talking about some features of laws. Just to remind ourselves that laws must be true, he says. That's, in fact, one of the things that sets Hempel's analysis of laws different than Lambert and Britten, because they're going to say, well, it may, strictly speaking, don't have to be true, and it turns out many of them, in fact, are false. But they need to be expressed in a sentence, need to be logically possible, they need to be universal. Conditionals by themselves can't do that, but you can get something in conditional form, because this is universal, This is affirmative, and this is one way of expressing the universal affirmative. This is another way. This way just happens to capture the right kind of logical relation that we need. That is, we want, if this is the case, then this needs to be the case. For Hempel, he also said that the predicates need to be purely qualitative. And then we're going to talk about another feature that they identify and that they need to support counterfactual. So I think Lauren's spot on in terms of her sort of translation here. I think the symbolic version in her presentation is a lot easier to read. I'll highlight it here. And to understand then, for any x, that is for any or every or all objects x, if x is such and such, then x is so and so. That works okay when you're trying to reveal sort of the form. I think what she wrote actually does a good job. So she's defined, where is it? UX as x is such and such, OX as x is so and so. But I think she's spot on here. Okay. All right. Your point C.
Kind of like what we already talked about. These are universal affirmative statements, for they assert that every object or event or condition that has certain properties also has certain other properties.
Can you give me some more examples in English of statements of this form? All S's are P's, or if something's an S, then it's a P.
All bachelors are unmarried.
So give me that same statement, but in a sentence that begins with if.
If something is a bachelor, then it is an unmarried man.
That works. Give me another example.
All balls are round.
And
If something is a ball, then it is round.
give me another example. Josh, you think of it?
All squares are rectangles.
Oh my God. All right. Give me a sentence that begins with if.
If something's a square, then it is a rectangle.
All right. Have you seen the logical structure there? That is, if something's a square, then it needs to be, how did you say it? It needs to be rectangular? What?
Then it needs to be a rectangle. I guess then it is rectangular would work as well.
Yeah, okay, that works. We're going to try to, the reason I'm asking you to give me some examples is I want you to avoid analytic statements here because they can't be candidates for laws because they lack empirical content, among other things. So a couple more examples. The last two examples are really bordering on being analytic.
If it's raining, there is precipitation.
No. If it's raining, then there is precipitation.
So then what?
Yeah, can you phrase that in a sentence that begins with all?
All rain is made of precipitation.
Such that if something is rain, then it is composed of precipitation? That's just an odd way of putting it.
Or all water molecules are H2O.
If something's a water molecule, then it's H2O. Yeah, we seem to be dancing around this analytic.
If something is a chair, then it can be sat on.
That is, all chairs are things that can be sat in. That sort of works, I guess. Are we familiar enough now with this structure that we see here? That we can go from any statement of this form into an expression of this form, but this sort of captures better what should be the causal or logical relation between the antecedent and the consequent, if it were expressed in the form of a conditional. Yes? I'm not entirely convinced. All right, I'll pause there, and we'll continue because we'll have an opportunity to discuss this more in a second. So let's go to the criteria.
So, laws are statements of universal form, as seen above, but not all statements of universal form are laws. Certain criteria must be met. The first is that these statements must have empirical content, and this is intended to rule out nonsense laws and spurious explanations based on them. Although they talk about how the exact distinction between sense and nonsense can be difficult to distinguish.
So laws have to be statements of universal form. They must have empirical content. And he talks about, for instance, all bachelors are unmarried men. Is that an example of an analytic statement? All right. What makes it analytic?
It's true based solely on the meanings of the words in the statement.
Right. It doesn't mean it's a priori, some would say, right? It's not true So that it's not, put another way, you don't learn this independent of experience, but knowing why it's true is something that isn't justified by experience. It's not contingent. It would be an analytic statement, right? Because analytic statements are going to be true in virtue of the form. In this case, one way of making an analytic statement is to have the same term. Now, would we want to say that all bachelors are unmarried men is meaningless? Do you understand the meaning of it?
It's just tautological.
Would it be true even if there didn't exist any bachelors?
As long as the concept existed, yeah.
That is, so long as we define bachelor by unmarried men, it's going to be true even if there don't exist any bachelors. Agreed? All right, so why doesn't it have empirical content? If it's analytic, why doesn't it have empirical content?
Because it's not necessary to be confirmed by external experience.
I don't. You got to speak up for one.
It's not necessary to be confirmed by experience.
Necessary to be confirmed by experience. I think you're on the right track. That is, it's the justification for knowing whether it's true doesn't rest on experience. That's why it doesn't have empirical content. So he talks specifically here is analytic statements, that is, statements true by virtue of their meanings of the words they contain, even if universal form are not laws. His example here is all paranoids suffer delusions of grandeur. Jones is a paranoid, therefore Jones suffers delusions of grandeur. What's wrong here in this particular example?
Well, yeah, actually, the symptom could be something empirical. He mentions it in the footnote that, well, actually, the delusions of grandeur or whatever could be almost like it is describing something empirically verifiable, because presumably that's what happens. We notice the symptom, and we make that.
Yeah, that's how I read it the first time I read it. I didn't see this as an example of something that's analytic, but they're saying here that we're defining paranoids as individuals who suffer delusions of grandeur.
It seems like that would be a symptom.
Yes.
Yeah.
And I sort of buy that particular one. Anything else we need to say about analytic statement? Lauren? I think so too. All right.
So they do kind of briefly mention how these distinctions seem very easy to make with the examples kind of given in the textbook, but they're a lot harder in a real world setting. So kind of there are issues with that. And the next criteria is that these statements must be true, but they go into, although this seems intuitive, it presents many difficulties. Many statements that are commonly regarded as laws hold approximately rather than certainly. And here they mention the classical mechanics, which I don't know that much about, but isn't it? It doesn't hold true for really, really big objects.
Or really, really, really small
Or
ones.
really small.
A really big fast ones.
So it's not necessarily true.
Yeah, let's pause here. This is a big deal. In fact, this is sort of the basis of the next piece we're going to be reading, the Cartwright piece, when she defends the notion that, well, it turns out most laws in science are false, strictly speaking. And the reason why they're useful for us is because we almost always add this, all things being equal. What they're referring to here is approximately, this ceteris paribus clause. All things being equal, Newtonian mechanics works, but there are conditions where it doesn't. So strictly speaking, if it's supposed to apply everywhere at all times for everything, then it's false. And a lot of laws are going to be false for that reason. So they work only sort of approximately within a certain range, right? So this is an issue because Hempel had just said in the previous lecture that no. One of the features of laws is they need to be true, right? We need to be able to deduce. Remember, in the deductive nomenological model, we've got a statement. That's the conclusion that's describing the event, right? That's the explanandum. And we need to be able to deduce it from the evidence, where the evidence in part needs to include laws. So Hempel gives us, as I just went over a couple minutes ago, Hempel gives us some, not necessarily necessary and sufficient conditions that must be met in order for something to be a law, but go back to my list. Laws must be true. That was his first one. That is, you're not going to be able to deduce a true conclusion if the premises aren't true. That is, you need the argument to be valid, but it also needs to be sound. So you need a law that's true. So he's stating that explicitly. And what they say is that, well, they may be true, but we're going to run into problems. He says And I like that paragraph. It begins with the first, that is, there are problems with this notion that they may be true. He says, the first is that many statements commonly regarded as laws, for example, those of classical mechanics, hold only approximately. They are not, in all strict sense, true. If we insist that explanation essentially involves laws and that laws must be true, we are faced with the unpleasant choice of saying either that, for example, Galileo did not really explain certain facts about the behavior of objects on inclined planes, or that he made his statements were true, but no longer are. Perhaps a less painful move is to relax the requirement that laws be true, and so on. The next paragraph. In this case, there are reasons for leaving it open for now whether laws must be true or not. We can do this by restricting our discussion to law-like statements, statements that are law-like if they satisfy all the other criteria for laws, independent of whether or not they have a truth value. Yeah.
Sort of in his definition of laws must be true. Doesn't he understand that the qualifications of a law being true? Like, is Temple saying that a law must extend indefinitely in terms of its coverage? Wouldn't Temple? It seems like Temple could be read at least in agreement with this. I mean, it's sort of like the Popper thing. Popper didn't explicitly say that falsification is the siding on this.
That is, we don't want to saddle Hempel with the notion that all law,
truthism or something.
yeah, that in order for something to really be a law, that it must be something that's true.
Because Hempel was just concerned with the logical structure, given that laws are true according to how we claim that they are true. But
Right.
I don't think it doesn't seem like in that piece he's advocating the truth of laws as being indefinite, having an indefinite coverage.
Yeah, I think that's fair. And in the same way that we don't want to saddle Popper with that naive falsificationist view that we can confirm and infirm the hypotheses or our theories one by one in isolation from other stuff, which is something we'll be talking about again today. Colas and stuff keeps coming out. Fair enough. But we tend to privilege laws as part of the necessary evidence we must supply in order to provide an adequate explanation. And until you take a class like this, you never really sort of consider what laws are. And we're being explicit, well, these are statements, and statements have the property of being either true or false. And you really want, when you're arguing, you've got to give evidence. That evidence will be expressed in the form of statements, and the evidence needs to be true. I mean, one of the principles of good reasoning is your evidence needs to be true. I mean, false evidence is always bad evidence. The problem will be that in the end, strictly speaking, many things that qualify as laws in science aren't true. So, can they really do the work that scientists or people like Hempel say they need to do in order for us to have an adequate explanation in science? In any event. And this is the second time you've encountered this law-like statements business. Hempel talked about them as well. So, is this an improvement? I mean, that is sort of saying, okay, well, we really don't need to consider whether the law is true, and we can instead focus on whether it's law-like. And law-like statements need to have certain properties in order for it to be a candidate for the kind of adequate evidence you need within an explanation that, well, maybe strictly speaking, it doesn't have to be a true law, but it's got to be at least law-like. And we can sort of limit ourselves to the identification of what those properties are. Is this an improvement or not?
I think it's a good addition to Hempel. I wouldn't say it's an improvement because it's almost a separate issue. Not a separate issue, but they seem to have two different priorities in the papers.
Yeah, that's true. That much is the case. But there's a lot of overlap between the story that we got from Hempel and the story that we're getting from these guys. And the story that we're going to get from Cartwright is going to be different than this story. So this, one way of looking at this particular piece is it's sort of a more refined version of the analysis that Hempel gave us last class. We're using a lot of the same vocabulary, a lot of the same properties when it comes to identifying, what makes a law a law. So it may be, for pragmatic reasons alone, better for us to focus on law-like statements rather than, strictly speaking, true laws. But we need to sort of continue fleshing out at least what law-like statement means. So I'll turn it back over to you now.
going to the third criterion, which is essentially that law-like statements support counterfactual conditionals, and non-law-like statements do not.
All right. So, again, all right, let's sort of set aside the issue of whether a law needs to be true, right? Let's at least focus on law-like statements. Because there are lots of statements of universal form that if all that were required for something to be a law was that it be expressed in universal form, then we'd have to admit a whole bunch of stuff as laws or law-like statements that we wouldn't want to do. So one way of getting around that is that genuine laws, law-like statements, support counterfactual conditionals. What the hell is a counterfactual conditional?
So they open with an example of two statements. The first being, all persons sitting on a certain bench in Boston are Irish. And the second, any body subject to no external forces maintains a constant velocity. They talk about how the first statement is actually an accidental generalization and doesn't really explain anything about how the world should or does work. And the second statement is a counterfactual conditional, which is a statement of the form, if A were the case, then B would be the case, where A is not actually the case.
All right, I think we need to flesh that out a little bit. Do you agree with, he labels these two sentences 1 and 2. Do you think that 1 expresses an empirical generalization? Or in fact, an accidental generalization? In what way?
Just because at that moment, if there is a gentleman sitting on the bench and he is Irish, that it is true, but that's not true all the time.
That's not true all the time, yes. It won't be true necessarily of every individual that sits on that bench. But notice that in 1, we've got a sentence that begins with the word all. Paraphrase this or rephrase this in the form of a sentence that begins with the word if.
If an individual sitting on a certain bench in Boston, if an individual is sitting on a certain bench in Boston, then that individual is Irish.
Yes. So we've got the kind of quasi-conditional relation there. It's universal, it's affirmative, but it doesn't express something that's a genuine law. It's an accidental generalization. It just happens to be the case. That won't apply. That is, it happens to be the case at a particular time, in a particular place. And one of the things that Hempel had said in the last class is that if it's true only at a certain time and in a certain place, then it's not a candidate for being a law. Laws need to have a more open range. It's not limited to a specific time and a specific place. But I don't think we really fleshed out what the counterfactual conditional is. So why doesn't that universal generalizations we just made, if someone is sitting on this bench in Boston, then that individual is Irish. Why doesn't that support a counterfactual conditional? Yes.
Is it that it doesn't explain why if someone doesn't sit on the bench, they're not Irish?
Yeah, counterfactual conditionals are, well, they're going to be expressed in the form of a conditional-ish, but the antecedent conditions never met. I mean, that's why it's counterfactual. Give me an example of a sentence that expresses a counterfactual conditional. Well, let me put it another way. Give me an example of a universal affirmative that supports a counterfactual.
Okay, a universal affirmative.
Yeah.
Um,
There's one, I've already given you one example, and it's one that you've seen a lot of examples of, a lot of instances of.
Would it be all bachelors are unmarried?
Now let's ignore bachelors. Right?
Would it be? Because I'm trying to think of an example where it's affirmative and the predicate is sort of almost like a negative. It seems like that's the sort of thing that supports a counterfactual. I'm not sure if I'm on the right track.
I don't think you all are, but here's an example that's sort of consistent with what you just said. All shoplifters will be prosecuted. Is it universal? Express that in the form of, in a sentence that begins with the word if.
If someone is a shoplifter, then they will be prosecuted.
All right. Why does that support a counterfactual? That is,
Because if they're not a shoplifter, they're not going to be prosecuted.
all students who cheat will fail.
So in the case where no students cheat, you're
That is, all students who cheat will fail. If someone's a student and they cheat, then they will fail. There's a sense in which that's true. Right now, as it applies to each of you, it's true when we leave the classroom, even though none of you are currently cheating, right? In the same way that there's essentially.
We might fail even if we don't cheat. We could fail even if we don't cheat.
But that's not the causal relation. That is, if you don't cheat, then you won't fail.
Yeah, it doesn't follow.
Is that supported? No. I mean, there are other reasons why you could fail, right?
Right.
So that doesn't support counterfactual conditionals. In order for something to be a genuine law, at least law-like, it must support counterfactual conditionals.
If something's a piano, it has keys.
What's the counterfactual there?
If it does not have keys, and well, no, if it.
Yeah, if it's not a piano, it doesn't have keys. My
Yeah.
ring in my pocket has keys on it.
Yeah.
So not a candidate for being a law-like. Can you give me an example of something that is a candidate for being law-like? Something that does support counterfactual?
Something like if a body is at rest, it tends to stay at rest.
I mean, that's just a statement of the velocity constant.
Yeah.
Right.
If something is large enough to fuse hydrogen, then it is a star.
Then it is a star?
Something is massive enough.
Yeah, if something is massive enough to fuse hydrogen, then it is a star.
I don't know. I don't know about that. The hydrogen bombs.
Yeah, does something have to be that massive to fuse hydrogen?
Yeah. That may be too technical. I mean,
Well, hydrogen bombs are fizzing. They're not fusing.
yeah.
Hydrogen bombs are fusing.
Yeah, that's the difference between atom bombs and hydrogen bombs.
Yeah, hydrogen bombs are fusing.
Yeah, we got to get away from this example.
Yeah.
We tend to think of,
Something is massive, it has gravity.
stop with the example. We tend to think of necessary conditions expressing not only what's required in a certain case, but that necessary conditions support counterfactual, such that if there really is a necessary relation between the two of them, then if this one thing doesn't happen, then this other thing won't happen either, right? And that's sort of at the heart of what counterfactual conditionals are. If, for instance, we analyze the concept of knowledge, the propositional knowledge, S knows that P, that's a different S and P here. If and only if S believes that P, S is justified in believing that P and P is true. So this is the justified true belief kind of knowledge. Have you heard this before someplace? So that if S knows that P, then S believes that P, S is justified in believing that P and P is true, where S is the name for some individual, and P is some proposition that that individual might claim to know. We would, if we apply this counterfactual bit here, we would say that it wouldn't be necessary that you believe that P in order to know it if it's possible for you to know something that you don't believe. It wouldn't be necessary for you to know that P, or it wouldn't be necessary for P to be true unless it were necessary that P is true in order for you to know it. I mean, there's a kind of counterfactual condition that's being supported there. That is, we don't allow anything to qualify as knowledge when any of those conditions aren't met. Now, we've been talking about conditionals a lot in this class. We've been talking about statements that sort of have this kind of conditional antecedent consequent relation, even though this, strictly speaking, isn't a conditional. And now we're introducing specifically this notion about counterfactual conditionals, and that in order for something to be a law, or at least law-like, it must support counterfactuals. The rub is that just about anything can be expressed in a sentence that has many of the features of laws, but not all of them. Genuine laws or law-like statements support counterfactuals in the way that accidental generalizations do not. That should be one of the take-home messages here. Yes?
I'm a little confused. Like the statement they gave about constant velocity, it doesn't seem to be counterfactual. Or like, it doesn't seem to have this trait. Like something can stay at constant velocity while having external forces subject on it. These forces just have to even out.
So their example here of statements of the form, if A had been the case, then B would have been the case. Where in fact A has not been the case. These are counterfactual. He says the present suggestion is that law-like statements support counterfactual conditionals. It's in the ability to support counterfactuals. Give me your example again. Here.
The sentence at the bottom of 227. Anybody subject to no external forces maintains constant velocity.
So what would be the counterfactual?
So you can maintain a constant velocity without being subject to no external forces.
You can maintain a constant
That's what that's
velocity.
saying, isn't it?
Yes. That's why it's law-like.
Okay, but you can also maintain a constant velocity while being subject to external forces. They just need to have a net zero effect on you. Like you could be, you can have gravity and
In fact, I like your example here. This is the all things being equal. This is the approximately. This is the ceteris paribus.
Yeah.
I mean, that's all things being equal, this
So it's-
works.
So it's not about counterfactual, that's not, almost not a counterfactual point, he's bringing up a point about Hempel again, about what qualifies as true.
Yes.
Because we can say, oh, we just mean the general sense, because.
well, no, I mean I think that statement, like that's not that my example doesn't make that statement false because I'm talking about bodies that are subject to external forces. So that's why I was saying it's like the counterfactual.
Well, if you read no external force as a net zero external force,
Yeah.
Right.
then
Yes.
I mean, okay.
I think you're onto something here. I just think it makes a different point.
Yeah.
Okay.
But this underscores why we do these 1 minute argument things. So the 1 minute argument question is going to have to do with counterfactuals and having you come up with an example. I need you to think about this more. You really need to get it, and it's hard to come up with examples on the fly.
So,
Yes.
so back to if we were to craft a counterfactual to all,
Speak up a little bit, Dan.
if we were to make a counterfactual to sentence 2 about external forces, wouldn't a counterfactual to that be something like, okay, so the first one is all bodies subject to no external forces maintains a constant velocity. Wouldn't the counterfactual be something like no body or any body or wouldn't the counterfactual be something like objects at rest tend to stay at rest? Because it's taking the negation of both and it still applies, or that conditional still holds. So if you have a body at rest and no forces are acting on it, it tends to stay at rest. Wouldn't that be a counterfactual?
Yeah.
Or
Is that consistent?
applying a force to it will cause its velocity to change.
Right.
Yes.
Okay.
Yeah, that's better. Point.
Yeah, that's a better way of putting it. You're just going to have to see some more examples written out because this
That makes sense.
it's an important point, but it's hard to see it when we're just talking about these language examples, but we're not actually looking at anything actually written down.
But basically, a valid counterfactual is one where that force of that if force, that if
That is the antecedent condition.
right, that
Is not the case.
yeah, that force still holds when you reverse the statement. That meaning that you reverse the conditions and it still applies.
Yes.
The relationship.
Yes.
So I think I have a good example of what I think it's not a counterfactual. Just see what's not a counterfactual. It's like if the individual is a citizen, then that individual follows all laws. That's not because not everybody follows the speed limit. Nobody.
So let's
So
try to
that's-
phrase this in the form at least an accidental generalization that happens to be true. So all U.S. citizens are individuals who obey all laws,
Mhm.
but that's false.
Yeah. I know. So that's not a counterfactual, right?
No, it wouldn't be.
Okay. That's I'm just trying to understand it.
I'll think of a better way of putting the form of this. And have you come up with some examples so that we can sort of, I know it's hard to, again, it's hard to come up with examples on the fly.
But
Can we just use like
Yeah,
scientific
just-
laws?
Yeah, just use scientific laws and then take their counterfactuals, just to say what happens should those conditions be reversed.
The only problem is if you don't really understand the science, right? Then it ends up, you have a kind of miscommunication that's occurring.
Fair enough.
what
Yeah.
about all good citizens uphold the social contract?
All, that is if someone is a good citizen or some person is a good citizen, then that individual supports the social contract.
Yeah.
All right, what would be the counterfactual?
If someone is not a good citizen, they do not uphold the social contract.
Would it be the other way around?
If someone does not uphold the social contract, they are not a good
They're not
citizen.
good.
That would be the counterfactual.
Okay.
And that works. That's true, I think.
Well, it's true by definition of citizen.
Yeah.
It's true by definition of good citizen.
Yes. good
That's,
citizen.
which is a relative term here.
Yeah.
I like the point that he makes below that paragraph when he talks about high statistical correlation. He says, good example with the smoking in healthcare. He says, a high statistical correlation should not be mistaken for a causal connection. Generalizations linking cigarette smoking and lung cancer do not support conditionals to the effect that if someone were, for example, to smoke 2 packs of cigarettes daily for a specified period of time, the chances of his getting lung cancer would be such and such. That is, it doesn't follow that even someone who smokes 2 packs of cigarettes a day is going to get it, right?
And some people get lung cancer who have never smoked.
This is true too.
Yeah, the counterfactual doesn't even hold. If
Does
you don't
not.
smoke, you won't.
Which, in this context, is important because one of the ways that you can mistake the cause of something for that is be mistaken about what's the cause of something is by identifying that there's a correlation that exists between 2 things, and if they're correlated, that one's the cause of the other. And strictly speaking, there are 3 ways the fallacy of false cause can occur, and one of them is that way, that just because 2 things are correlated, that is, that one always follows the other, it doesn't follow that one's the cause of the other. The example that I have in my logic book is that
It's a hot day.
that an increase in crime always occurs with an increase in snow cone sales. Therefore, the increase in snow cone sales causes the increase in crime. I mean, there is a correlation, but the correlation has to do with the heat, right? People get more snow cones when it's hot, but they also have an increase in crime when it's hot. The idea is that you don't have the right causal relation. That is, correlation doesn't imply causation here. So this is part of the reason why he wants to talk about these high statistical correlations. Correlation ain't causation. And again, we're in the business of trying to explain how it is scientists are able to explain things, and you need to do more than simply identify a correlation. That correlation doesn't lead to the right kind of causal relation that you need in order for it to be adequate. I like the discussion after that. It says, we take it then that it is apparently a necessary, if not also a sufficient criterion for being a law-like statement, that a statement be of universal form, support conditionals, in particular counterfactual conditionals. The usefulness of this criterion depends in part on the sureness of our grip on the notions of support and counterfactual conditional. And yeah, absolutely it does. Yeah. And we're struggling with it because it is a little difficult to get. One way of analyzing such conditionals in terms of so-called material conditional, he says, of classical logic, will not work at all. The material conditional, that is how we typically define the truth of statements of this form, if P then Q. This has the form, as you've seen, of a conditional statement in the language of sentential logic. And the way that we define its truth is that any statement of this form will be true provided that the antecedent's not true and the consequence false. When the antecedent's true and the consequence false, the whole thing is false. Otherwise, when the antecedent's true and the consequence true, the whole thing will be true. When the antecedent's false and the consequence true, the whole thing will be true. And when the antecedent's false and the consequence false, the whole thing will be true. The problem with this definition of the truth conditions for a conditional is that is this what's called a material conditional, is that counterfactual conditionals are always like this. That is, the antecedent condition is never realized. That's why it's counterfactual, contrary to fact. And strictly speaking, on this analysis of what makes a conditional true, every counterfactual would be true, simply because the antecedent condition isn't realized. So the material conditional that we use in sentential logic really doesn't help illuminate how counterfactual conditionals actually work. So he says material conditionals of classical logic will not work. The material conditional of if P then Q is so defined as to be true whenever P is false or Q is true. Since the antecedent of counterfactual conditionals are always unrealized, that is, P is always false, counterfactuals construed as material conditionals will always be true. I think we're at your point D now.
Okay, so their solution to this issue is to treat conditionals as enthymematic arguments, in which the antecedent of the conditional is made up by the premises of the argument, and the consequent contains the conclusion. And with an enthymematic argument, it's a syllogism in which one of the present premises is implied, and the implied premises in these arguments would then be the laws needed to support the argument.
Strictly speaking, again, that's a form of a conditional. Laws need to be universal generalizations. We can't do that by giving a truth functional compound statement that consists of an antecedent and a consequent. But sort of what they're looking at is, well, in order for this to be a candidate for something with empirical content that is universal, well, we can't write it in this form. We're going to need the logic of predicate logic here. So for any x, if it's a p, then it's a q. Well, that's sort of closer. But what's missing here? That is, in order for this to be a law-like statement, a candidate for law, what's the missing bit for this style of syllogism?
Is where you put in the laws needed to support.
But aren't we expressing the law this way?
Are you asking what's missing in the expression itself?
Yes. So again, Lauren's right in for identifying this particular paragraph. Says a more promising suggestion is a condition that we treat them like an argument with some missing evidence, right? And there's a sense in which it's okay for us to consider pretty much any argument to have some missing evidence, because there are always going to be statements that we're implicitly assuming and not stating explicitly. And you already know that. I'll show you another argument here. This is a pen that's not working. This is an argument form that you've seen many, many times. It has a name. It's modus ponens, right? If P then Q, P therefore Q. One of the things that we can do when we express arguments is to put them in the form of a conditional statement. That is, where the antecedent will be a conjunction of the premises and the consequent will be the conclusions. If I were to write this argument in the form of a conditional statement, it would be if P then Q and P then Q. That's a conditional statement whose antecedent is a conjunction of the premises and whose consequent is the conclusion. So if we, now we got the conditional statement bit, but we can't just go from this into an expression that begins with this, because we're talking about two different systems of logic. So the issue is, if we, in thinking about these counterfactual conditionals, consider them to be a kind of an argument where some of the evidence is missing. What's the missing bit here? Yeah.
That these only apply to individual. That those the argument in that form only applies to the one-by-one confirmations.
Yes. That's why these are singular statements as opposed to universal ones. And I can't mix my systems of logic. I can't just do this, right? Because for any x,
If P then Q.
I mean, that doesn't make any sense. I can't even express that. Here's an example. If I were to write this argument here, if P then Q, therefore Q, what's missing is P, right? This is incomplete. If I were to evaluate it just on the basis of that premise alone, well, that doesn't follow. But if we assume this and P, then I can deduce this. And that's sort of what's going on here with the counterfactuals. That there's something that we're assuming that's not being stated explicitly as a part of what makes a law a law, what makes a law-like statement a law-like statement. And it's a difference that makes a difference. So, do we have any other examples of that here? Have you made both the points below D here, Lauren?
Yes. I think with the example, 3/4 of the way down on 230, all pieces of copper wire at -270 degrees Celsius are good conductors. You could kind of use that because they talk about how there's no real empirical evidence for whether a piece of copper wire at that temperature would be a good conductor, but you have this system of laws within which you can kind of figure out how that would be true. I think I'm skipping with it.
You are, because it sort of occurs in the context of holism, that there's other stuff that we need, but it's related, though, here, I think. So what's the final feature? He says, law-like statements, in contrast to acts of generalizations, are confirmed by their instances. You make that as the second point. What's going on here? You say issues with the solution.
Well, they talk about how this does create kind of another circle, like we talked about with the hermeneutical circle.
Right.
But with generalizations, you can't say, for example, with the gentleman on the bench in Boston, it isn't true with every case. But whereas with these, you can kind of confirm them.
And these being what?
Oh, with the law-like statements rather than just generalizations.
All right, then what's the difference between something like all ravens are black and all pieces of copper wire at negative 260 to 70 degrees Celsius are good conductors?
Because with all ravens are black, you can find some instance in the world that where a raven isn't black, and it disproves the statement.
Or I could even imagine a situation where all ravens are black, but some raven might come along in the future that was not black.
And there are, in fact, albino ravens,
Yeah, right.
as we
Yeah.
discovered.
But I mean, like, you could always paint a raven white, it doesn't quit being a raven.
But it would still be black. It would just have white paint on it.
Yeah, that's true.
Okay.
But in the case of a genuine albino
Albino.
raven, that is, we've got lots and lots of evidence for the truth of the statement that all ravens are black. But is that a law?
No.
I mean, does it follow that the next raven you see is going to be black? No, it's not. But this is consistent with the notion that law-like statements, in contrast to acts of generalizations, are confirmed by their instances. Well, isn't there a sense in which we're confirming the truth of all ravens are black every time we go and we see a black raven? So how does this work here? That is, what's the difference between a law-like statement in contrast to an accidental generalization being confirmed by the instances?
I think with that, it doesn't really give, or with the example of a generalization, it doesn't really give any kind of a explanation as to how the world works.
Explanation or causal relation.
Yes.
Right, that's what's missing. And that, in order for something to be a genuine law-like statement, there needs to be that. We don't have that. And reporting the almost true universal affirmative statement that all ravens are black. Turns out you just need one non-black raven in order for that to be false. But just because we've observed this again and again and again, it doesn't mean it's a law. I mean, there's no necessary relation. We're just reporting something that we've observed. It's an accidental generalization, right? Right? It's not candidate for being a law, even though it's universal and that's required. And we could express it in the form of a conditional, like if something's a raven, then it's black. But we're not capturing any sort of causal relation between the two there. But what I don't understand here, that we're trying to flesh out, is how one supported or confirmed by their instances and the other isn't. We've already identified some problems with confirmation and with verification. So is this, really doing the work it's supposed to?
It says it has to fit within the framework,
And in the framework of what?
the larger body of knowledge.
And that's the more important issue here. This is just another reference to holism. He says the difference, rather, seems to lie in the fact that the copper conducting statement is systematically connected with the larger theoretical framework, whereas the unicorn fleeting statement is not. To put it in a slightly different way, what enables us to call the first but not the second law-like is the position of the first in an existing body of knowledge, in particular, whether or not it has any positive instances. It will be granted law-like status. It follows from other laws and other theories. This is an important point. This is a point that We've already considered, when we're talking about falsification, right, that we can't really falsify our hypothesis or our theories one by one. We can only do it sort of as a corporate body. So it's really naive to think that when we're testing a hypothesis, and if our hypothesis is true, then we ought to observe the world being a certain way. And we don't, therefore we conclude that our hypothesis is false. We just chuck it. Because it's never going to be the hypothesis. It's always going to be the hypothesis along with a certain set of auxiliary assumptions. What makes something a law-like statement, as a candidate for being a law-like statement at least, is the way that it fits within the framework of other statements that also include laws, that allow us to say that it's consistent with, it's conservative with. There are these other virtues that we'll get to eventually. That laws or law-like statements have this property, but accidental generalizations do not. Does that make sense to you? 'Cause I do like that point. The next to final sentence, he says, generalizations that are not systematically connected with other laws are merely accidental. Yes, accidental generalizations are not candidates for being laws. Lauren, what else we need to say here?
That's pretty much it.
Also, though, when they do talk about generalizations not being laws because they're accidental, they also rule out potential cases that scientific theories could allow. And they talk about a non-Irishman sitting on the bench.
Yeah. All humans are mortal. This is universal. It's affirmative. If I were to express this in a sentence that begins with if, I would say if something's human, then it's mortal. And I can even symbolize it in language of predicate logic. For any x, if it is human, then it is mortal. Is this a law? Or at least law-like? I mean, is there a causal relation between the one and the other? Not so much. If something's not mortal, then it's not human, would be the counterfactual. And, well, is that the case? No, not really.
I mean, I don't know. I don't know of any immortal humans.
But
I
that
don't
doesn't
know any
mean,
of dead humans either, not normal.
But you might not know of any white ravens either.
Yeah.
yeah. I mean, there's no necessary connection between being a human being and being mortal.
Well, that would, I mean, if there was a necessary connection, that would make it analytic and not empirical.
Well, in that sense, that's true. Think about it like this. All creatures with a circulatory system are creatures with kidneys. I mean, is there a necessary connection? It just so happens to be the case that you don't have a creature with a circulatory system that doesn't have kidneys. Wouldn't live very long. I mean, you pluck them out. So we need to be on guard against analytically defining things in that way. So is there a real necessary connection? Well, there isn't anything that's true about the world that's necessary in that way.
Yeah.
There isn't anything alive with a circulatory system that doesn't have kidneys?
There would, huh?
There's nothing that lives with a circulatory system that does not have kidneys?
Think
Or
about
lives for very long?
somebody getting an operation, you know, and their kidneys get removed as they have other kidneys being implanted in them. I mean, they're still alive, they're still human
Something
beings.
that forms the function of kidneys.
Yeah, well,
Yeah, then I'm,
yeah.
Or for that matter, somebody on dialysis might pretty much have non-functioning kidneys. Got a machine taking its
Yeah,
place.
machine.
Yeah, I think that works. I just want us to make sure that we can recognize the difference between an accidental generalization, something that's universal, it happens to be true, or all things being equal, right, versus something that's really law-like, as a candidate for being a law. And this is definitely not something that's going to be a candidate for being a law. Yeah.
I don't know. It depends on. I don't know. I feel like the humanity is something that is like.
Like you can talk
It
about how
rests
cells
like
die.
that. Like there's no humanity without mortality.
Well, that's a separate issue, though.
There's no existence without.
But it makes it causal, is what I'm trying to say.
What? There's no existence without what?
Everything that exists will one day go away. All things that exist will one day disappear.
If we assume certain other things as a part of the framework that we have, yeah, sure, entropy and all that.
If we were to assume the universe is an immortal crystal creation by a all-powerful deity, it might not be that it would ever go away.
Yeah.
I mean, if you just take a different set of assumptions, it may not be as reasonable an assumption, but
Yeah, that's what Plantinga does, actually. He's pretty good at that. He says, well, if you take naturalism and certain claims about knowledge, for example, you can't take seriously because knowledge is the product of evolutionary forces, and they are not teleological, therefore they're just accidental. But if you take theism, I can provide you with knowledge.
Yeah, he is an apologist. In fact, he's probably the best known
Yeah,
apologist.
he's really good.
He's pretty good. But the issue is that a candidate for a law? I mean, is this law-like? I mean, do we roll all humans are mortal? I mean, there isn't a necessary relation between the two, but is it possible for something to be human and not be mortal?
Could we restate it as something like anything that is composed of this certain cellular structure and matter will die according to the background assumption of the law of entropy?
Well, we're getting closer there to something that would be a candidate for a law. But I don't
understand why this isn't.
Why it's a law?
So
Why
long as we
it's not a
clarify,
candidate for a
so
law.
long as we clarify what we mean by human in terms of scientific descriptions, it seems like it could follow as a law.
yeah, if
according
we
to
spread it out into a big, we put a bunch of assumptions that went into being human
Right.
and being mortal, then maybe we could turn it into a law, but like that,
it's not
just a
sufficiently
statement.
It's not sufficiently described as that, so it couldn't be a law.
Yeah, in order for us to make this something that would be more of a candidate, we would need at least operational definitions for the terms human and mortal in order to identify what we ought to be able to observe on a particular apparatus when we perform a particular test. In order,
So we just need more clear definitions of those two words for this to be considered a law-like statement.
And then correlation.
you need the causal correlation, and we really don't have that here.
Provide that if we define humans in a way where like entropy could act upon cells, for example.
Yeah, the reason why I mentioned this particular example, and there are lots of other examples we could talk about in this context, is one of the issues we're going to have is how do we go from the laws to the statements describing what we ought to observe as a part of sort of the test for a hypothesis, right? And we're going to have some folks who are going to defend the notion that laws need to contain theoretical terms. But when we actually perform the test, we're going to need statements that describe what are called observation terms. We need some way of going from the laws and the theoretical terms to true statements with empirical content that we can verify or falsify. And there's going to be an issue here because what we've been sort of assuming is that it's not going to be just through definitions that we're going to be able to get the kind of clarity and precision that would make that a candidate or make this the precursor to a candidate for something that could become a law. But it is presupposing that there's this fundamental cleavage between theoretical terms and observation terms. And Putnam, who we're going to be reading, is going to defend the notion, no, there ain't. There is no pure distinction, and there isn't anything that is there any statement composed of theoretical terms that precludes it from including observation terms as well. Yeah. Well, that's for a different reason. I mean, it's the same guy. So we're not done with this. And again, this is just one piece where we're focusing on the nature of laws and some problems of laws. But for the most part, these guys give us a story that's consistent with the Hempel picture. We've introduced a couple of things which may or may not have helped, that is this counterfactual stuff. But I think you're more or less in the right ballpark when it comes to what makes something a law. But we're not done yet. So we've got one more piece where we're going to consider this, and things should be coming all together then. But even after this week, we're still going to be considering what laws are and some problems with laws and their role in scientific explanation. So if it's not all perfectly clear at this point, that's okay, because we've got more material we need to get through. But I will put some thought into the 1 minute argument question for today, because I really do want you to consider this counterfactual business a bit more. Okay, do you have anything for me? All right, then I'll see you on Thursday.